This is a NU.X Horseman pedal, which is a clone of a 1970s guitar pedal called the Clon. I've done a repair on a very similar NUX pedal. I don't know if it's pronounced NUX or NU.X, but I'm going to say NUX. I did a repair on one of these not too long ago. Didn't really make a video about it or anything, but I've picked this one up broken, and it exhibits the same fault, and I think it's the same condition. And as it's come up a second time, and it's quite a delicate repair, I thought I'd cover it on this one because I believe it's going to be the same cause. These pedals have a dual bypass mode. The actual switch is not a standard mechanical switch like you get on most pedals that does true bypass. The bypass mode on these is controlled by a microcontroller, and they can either do a buffered bypass mode, which isn't true bypass. It means the signal stays through the buffer amp and it's electronically turned in and out, or it can switch to another mode which uses a relay, which actually does a physical true bypass. So it will physically route the signal through the relay directly to the output if you have the pedal bypassed. That mode is set by holding the button down and connecting the power, and it switches the mode. I believe this pedal to be currently in the buffered mode because the fault is that there's no sound at all, whether it's turned on or turned off. At this moment there should be a 1 kHz test tone going through that, and you would be able to hear it. Notice in both modes it's silent. Now if I undo it, you hear the test tone straight away. So that's gone into its standard bypass mode. If I hold down the button and connect the power, now note what happens. Now that we're in true bypass mode, going through the relay, it works. The electronic buffering, the switching, in the last one I opened, and I'm assuming this is exactly the same, is done by a multiplexer chip. The button sends a voltage to the microcontroller, which turns the multiplexer on or off, or routes the switch if you like. And in the last one I repaired, that multiplexer chip, which I think was a 4052 if I remember correctly, had failed. And I was able to see on an oscilloscope that that chip had failed. And I did have some in stock. I swapped it and got it working. The previous pedal that I had was a compressor pedal. I've forgotten what it's called. I will mention it elsewhere. I know, it was a sculpture pedal, a NUX sculpture pedal. Exactly the same format. So I think in the same way that a lot of these cheaper pedals are made, they come up with one stock design, one stock control mechanism if you like, and then put the dedicated electronics or sometimes even just software for a DSP in there, and give it a different coat of paint, and one design becomes 20 different pedals. We'll see what's going on with this one, but I reckon it's going to be much the same fault. So we'll open it up, see if it consists of what I think it consists of. Opening up the unit, you can see this consists of two separate circuit boards, which has a little mating connector. It's just a pin header here and here. So all you have to do is take the screws out, loosen the nuts on the side of the jacks, and then just very carefully pull the board straight up and it comes out. This chip here, which I hope I can get just in macro focus there, is a 4053, not a 4052, and that's the one that I changed on the last one that I repaired of these, and I've got a feeling it's going to be this exact same chip that is faulty. So I'm going to cobble something together and do some tests on this chip to see what's going on. What I've done here is just take an ordinary male to female DuPont header cable, because this just uses standard 2.54mm DuPont headers basically, and just made an extension cable between the two. You just have to be really careful that you connect the relevant pins to the relevant pins, that you don't cross any over. And if I plug this in now, we should see the light come on. You can just about see that in my light, and there we go. So That allows me now to have quite a bit more room to look at the chip on the back of this board. If I carefully turn this over, which is here, this is the microcontroller chip, and this is the multiplexer chip that we're interested in. Gives us much more access now. Otherwise the sockets from this board, if they were together, would be right over the top of this, so you wouldn't be able to get in there to examine it. So I think I'm actually going to bring something in just to hold this board in place so that I can probe around this chip and see what's going on. Okay, here's the pinout of the chip that we're going to look at, and here's the tiny chip that we're going to look at. We can see from the top here the ground pin and the VCC voltage supply pin are pins 8 and 16, because this is upside down. This matches the layout of the chip there. So this matches the orientation of the chip there. So I'm just going to have to pop that on top of there a second, and because it's the only way I can get it in shot, and just see if we've got voltage across there. And we do. That's the 8 volts from the battery, so it's down a little bit, but we know we've got power to the chip there, so that's fine. Now on the 4053, it basically consists, if I bring this diagram up here, a single pulse switch that you can have 1 input and 2 outputs, or 2 inputs and 1 output, a control input, and an enable or inhibit input, which can disable it completely, so think like a mute control. And in a 4053 there are 3 of these switches discrete from each other. So we've got 3 control lines, 1 enable or inhibit line that can enable or inhibit them all at once, and the 3 individual switches. So there's 6 connections there for the switches in total, plus the control, and of course the power. So we want to be able to see if flipping the bypass button when it's in buffered mode on the other board changes the control signals. So we need to look back to the other diagram, and the control inputs are the address pins A, B and C, so the top 3. So we should see some change in signals on these when we toggle the button in buffered mode. Okay, I've clipped the ground side of my meter to the ground tie on that screw hole there, just to make this a bit easier to do with one hand. Let's check these 3 address lines, and we'll check the inhibit line on the other side of the chip. So the top 3 address lines, the first one's on, the second one's on, and the third one's on. And let's just check the inhibit line. Nothing on the inhibit line, and I believe inhibit is not marked with a line across it, so inhibit would be active if that signal was high. So all the switches aren't inhibited, they should all be active. Now let's see if we get any change. I'll carefully do this with my other hand. On any of these switches, yes, I've just changed the mode there, just press the button, and you can see A is toggling, B is not toggling, C is not toggling. So the only one that actually changes in that mode is A. I'm going to change the mode to true bypass, so I'm going to have to undo the power, push in the switch and reconnect the power, and we'll see if that makes any change to the state. So the pin's still high, and I'll reach underneath. Now I can hear the relay changing, and notice now it stays high in the different state. There's a slight change there, but it's not enough to toggle the switch. Just checking the others. Again, in true bypass mode with the relay, the switches don't change. So I'm going to switch that back to true bypass. Verify that we've done that. by toggling that again, we should see that change. Yep, so we're back in buffered mode. Okay, my camera card ran out, so I've got a little bit to make back up here. We know the modes that the 3 address lines are working in. We know we're back in buffered mode on the pedal. So what we need to look at is channel A on this switch. We have a common and then a normally closed and normally open. If we find a signal that I'm going to inject from a signal generator on one of these pins and change the button, we should see the signal jump to the other pins depending on if it's coming input or output. If we don't see it move, we know, because we know we've got the logic signal, the switching signal working, but if we don't see the actual signal that's being switched move from one pin to the other, we'll know we have a fault in this chip. We know the inhibit line is low, so it's not inhibited, it's not muted. But if we don't see it move, then we know we've got a problem with this chip. So I'm going to set the frequency generator quite low. I'm going to set it to 300 Hz because the frequency count on the meters like this isn't super high. It's reading 50 at the moment because it's picking up mains interference. And I'm doing it on my fluke meter because unfortunately my scope is right next to the camera, but I can't, I don't have a second camera to point at the scope without holding a phone with another pair of hands, which I don't have. So we're just going to do it with the frequency counter on the scope. You put the scope on the meter, sorry, you put the meter into AC volts, press the yellow button, it gives you a Hertz reading. Now we'll need to look at pin 3, 4 and 5 on the chip. So having already done this earlier when the camera ran out, I know that on pin 5 there's our 300 Hz count. So we should be able to see that on one of the other pins, and you notice we don't. It goes silent, it's dead. So it's as if the pins are stuck low. Now toggling the switch on the pedal, if the switch was working, if the multiplexer chip, sorry, was working, it should make that 300 Hz signal appear on one of the other pins, and it's not. Just like the one I repaired. There's our original signal. It should be working. I can see the light underneath going on and off, so I know that the pedal is being triggered in and out of effect or dry, and we're not seeing any signal come back through the multiplexer. So I do have reason to believe that chip, just the same as the other one, is faulty. So I think the next step is going to be to mask off these tiny little components around here with Captain tape, and get some flux and hot air on that chip, remove it. Actually, before I do that, I need to locate my spares of these, make sure I have actually got one before I take it off. I'm pretty sure I've got a tube full of them, which was actually bought by mistake for something else, and the size I wanted was slightly different. But then these have come in handy, they were quite cheap as well. These have come in handy for pedal repairs and things like this. So next thing is get hot air, get that chip off, get another chip on, and see if it makes a difference. Okay, lightly lead-free solder. So I'm going to set the hot iron at the hot air at 380 and get in there. So we've got some chip quick flux on there. I have found my spares, thankfully, so there we go, and that's off. Not too bad. Captain tape is an absolute miracle. Without it, those two tiny resistors there and that tiny transistor there would probably be in another town by now. So Captain Tape's a huge necessity. So luckily we've got the legend on the board for the from the screen print that shows us which way the chip goes. I think what I'm going to do is put a bigger tip on my iron, and I'm going to get some more flux and some braid and take the solder off those pads so that they're nice and flat for us to be able to get the new chip on. So let's pop the iron on, find the braid. And my preferred way of using braid is to cut it into really small pieces. I find if I use the entire roll, it tends to wick all the heat up the roll. I'll have it in really small pieces, and I have this tiny little silicone, it's almost like a oven glove but for finger and thumb. I really find this helpful, so you don't burn your fingers. Some people when they're soldering, they go right up to their fingers and it's not a problem for them. I'm afraid I'm a big baby and I take all the help I can get, and that was a little thing I found on eBay, and it's been really helpful. Okay, that's looking pretty decent to me. I'm going to turn the iron off, so I'm going to swap the tips over, get a new chip out. The replacement chips that I've got are Philips chips from 1993, some new old stock that I picked up, and these have been really dependable so far and what I've put them in, so I'm going to pop one of these in. So the stripe goes at the bottom there. I've swapped the iron tip to the hoof tip. That's the one I like for drag soldering and most general work, to be honest. I'll swap to the hand. I should be able to drag solder this. And drag solder. Like that. That's pretty good to me. That's it. Just going to have a look at that with a loop. Alright, real quick because my battery's running out on my camera. Listen. 300 Hz tone. Press the button, the pedal's working. If I turn the controls on the bottom, that is working. That's my main gain. That's the treble control. It works. So again, faulty multiplexer chip. So there we have it. I put it back together, tested it, it's all working. Yeah, second one of these NUX pedals that I've done this repair on. This is basically brand new as well. The board is even stamped 2021, the batch number on the actual board, and the circuit design is 2018 according to the screen print. As you can see, it's obviously brand new. The screws clicked when I opened them, so it's never been opened. I think it's got 2021 in the serial number. So for all intents and purposes, this was brand new. Kind of makes me wonder with that original chip. I'm trying to find the manufacturer of it to no avail, but it's hard to say really. Is that just a crap chip, or is it a flaw in the circuit that leaves it open to transient damage or something like that when it's being plugged and unplugged? Don't really know. They're not the strongest things in the world, these little pedals. That kind of format of sandwich circuit boards is becoming really common in the TC electronic pedals, for example. Use a similar sort of thing with the button mounted on the circuit board instead of an actual physical changeover switch. they're not the toughest things, I would say, for live use. You know, you wouldn't want to go kicking one of these around, stomping all over one with your boots in a gig on a Friday night in the corner of a dark pub. But I think for kind of general use and studio use and that sort of thing, for the price you get them for, I think they're pretty decent for what they are. And if you can pick them up like I've picked a couple up for next to nothing and fix them and keep them, I think that's well worth doing. I'm happy to do that. But if you have one that's exhibiting exactly the same symptoms, where it doesn't work in the buffered mode, try holding down the button, put your power in. If it works in bypass mode, or if it passes the signal through in true bypass mode, definitely suspect that multiplexer chip. And if you feel like you're up for it, by all means, you want to do the surface mount soldering, pick up a chip and swap it. These little cables as well are well worth picking up. A lot of pedals seem to use that sandwich design with the DuPont headers in between. These are a couple of quid on eBay, if that. Really useful for extending the board so that you can get in there and test them. But yeah, I hope that's useful to someone who might have one of these with the problem. You might give you an idea of what to do about it, and I'll see you in the next video. Cheers.